extension of the game where we're trying to find the missing exponent or base in the future. So remember the notation, this bottom number that's being multiplied will be the base, and the exponent tells you how many times you're supposed to multiply it. So this is a very, very important observation. How many times do we need to multiply 10 by itself in order to get 100,000? I'd say 1, 2, 3, 4, 5 times. Okay? So you can try it, right? If you multiply by 10, you just kind of add a 0 at the end. So in this case, we need to have 5 zeros, so that's going to be 10 to the 5th, right? They're very, very useful for scientific notation. So in this case, we'd say this will be 10 to the 3rd because there's 3 zeros, right? 10 squared because there are 2, 10 to the 5th because there are 5, and then when we deal with something that is not base 10, right, we have to think, how many times do I have to multiply this to get 36, roughly, right? In this case, it's 2 times, because 6 times 6 will give us 36. In the future, these problems will be slightly harder because the bottom might not be an integer, and the top might not be an integer. So it can be a little bit more confusing. But in this case, 3 to the 3rd, right? 3 times 3 is 9, times 3 is 27. 2 to the 3rd equals 8. 6 to the 1 equals 6. And as we continue, anything to the 0 power equals 1. 10 squared equals 100. 8 squared equals 64. 5 cubed equals 125. 2 cubed equals 8. 3 to the 5th will equal 243. 10 cubed equals 1,000. 2 squared equals 4. 9 squared equals 81. 5 squared equals 25. 1 to the 4th equals 1. 1 to the 3rd equals 1. And now we're in the challenge zone. All right, so how many zeros are here? I'd say 6 in a million, right? So 10 to the 6 is a million. 10 to the 9 is a billion. 10 to the 10 is going to be 10 billion. 10 to the, what is that? Sorry, this is, I mistyped, 7, right? So 1, 2, 3, 4, 5, 6, 7. That's going to be 10 million. 3 to the 4th is going to be 81. And you'll notice I've been doing these quite quickly. And the reason is I wanted to show you kind of what speed you should actually have. So in this case, when we deal with it, we're looking at 3 times 3 is 9, times 3 is 27, times 3 is 81, right? Anything to the positive integer power will be something other than 0, which stays the same, okay? So in this case, we're saying 3 to what power equals 729? If we don't remember from earlier, we can always, again, multiply it out and just count along. So if we just kind of count our fingers, right, we'll have 3, and then 9, 27, 81, 243, and 729. So that's going to be 3 to the 6th. Over here, it's going to be, and if we didn't know, right, we can still count along. So we say 2, 4, 8, 16, 32, 64, which is 2 to the 6th, right? And the last one, if we just extended from 6, we just go straight to 7, it'll be 128. So 2, 4, 8, 16, 32, 64, 128 is going to be 2 to the 7th